Here we go. What is a ratio? A ratio is a comparison of two or more quantities. Two or more quantities. And I'm going to do you a favor. I'm going to come back. I'm going to type these. Get them typed here. A comparison. Why are we not typing? Okay, it's not going to type. Why are we not typing? Cool. We'll go this route. Sorry. Man, this has been a day. More quantities. Ways to represent ratios are a fraction. So A over B, or as a statement, A to B, or as a with a colon, A colon B. And then ratios can be simplified, which means reduced. You probably heard it as reduced. That means taking like 5 over 10 can be simplified down to 1/2. Okay, so then let's look at this setup it has for us. We're just going to do 1 and 2 for the sake of time. A music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, 16 trombones in stock. Write each ratio in simplest form. Simplest form. How many trumpets do I have? Trumpets came first, so that's what I'm going to write on top. And then it asks for violins. How many violins do I have? There's my ratio, 40 over 24. But I can also simplify this ratio down. They are both divisible by 8. That would give me 5 over 3. That's my ratio, 5 over 3. For every 5 trumpets, there are 3 violins. Flutes to clarinets. How many flutes do we have? 51. How many clarinets? 39. Now, I'll be honest with you. I don't know my factors of 51 and 39, but I can take my calculator and you can type alpha x, and then it gives you the ability to type in that fraction, 51 over 39, enter. It reduces down to 17 over 13. And there is my, my simplified ratio of flutes to clarinets. Okay? What is a proportion? A proportion is an equation that states 2, and it really, in my opinion, should say 2 or more, but 2 ratios are equal. So it's saying that when we compare ratio number 1, a proportion says it's equal to the ratio number 2. Proportions written as, and the letters just are placeholders for numbers. A over B is equal to C over D. And you can use this thing called cross product property to solve any proportion. So when you have A over B equal to C over D, you can solve it by multiplying A times D, setting it up equal to B times C. And I like to highlight these to make it kind of easy to see visually. I will have these notes posted in Google Classroom this afternoon. Nope, that should be green. Yes, sir. Times, multiplied. Yeah, multiplied. Okay. Now I'm not going to do any of the cross product stuff today because I think it'll show up tomorrow. I will have a video for that tomorrow. You can go from there. Let's go to the note page that says similar polygons. And I do have those already typed up, so I'm going to erase these notes here and let you type what you see here. We'll come back in a second and talk about those. Francisco, you should be in Tel Pass. Have you already done it? Yeah, that's where you should go. Yeah. Thank you. Yes, sir. Asa, is Asa in here? I didn't think so, no. Yeah, you can just shut it there. Yep. Hey, all of this will be in Google Classroom, Francisco. Okay, looks like everyone's done writing and y'all were waiting on me. Polygons, similar polygons are polygons with the same shape but a different size. Polygons are similar if corresponding angles are congruent, which means they equal. Corresponding angles are proportional, corresponding sides. So if polygons are similar, meaning that they are the same shape but different size, then the angles inside the two objects will correspond with one another. There will be angles that are equal to each other inside both objects. Corresponding sides are proportional, which means that there is a proportion between all of the sides of triangle or object 1 and object 2. So we're going to set up a ratio over, say, object 1 over object 2. And for every side that we would put into those ratios, there is a consistent proportion throughout them. It'll make sense in a minute. A ratio of corresponding sides is called scale factor. So that scale factor, every side will have a scale factor. And if polygons are similar, then their perimeter are also proportional, or their perimeters are going to create a scale factor as well. So then, let's look at what is the scale factor of triangle ABC to triangle DEF. Let's first look at the angles. Does angle A have a matching congruent angle in the second diagram, or second triangle? Yeah, it's D, right? What about angle B? Does it have one? Yeah, it's angle E. And then what about angle C? Right, it's F. So what we did right there is this right here. corresponding angles are congruent. All of them were. That we found a matching congruent angle in both diagrams, both triangles. Okay, so I can actually write this similarity statement, which is, we're not quite there yet, but I'm going to go ahead and say it. Triangle ABC is similar to triangle DEF. Okay, I'm going to write it there. We haven't talked about similarity, the symbol yet or any of that, but I'm going to write it there. And this looks very much like when we did congruent statements. You all remember those? Yeah, I would hope so. Where we said the first letter and the first object goes with the first letter and the second object. And then we said that second letter or angle that it represents goes with that second letter, and that third one goes with that third one. Well, when you're doing scale factor, you can kind of use that to help guide you. Because what I know is that there is a distance between A and B. Right? Between A and B, there's that distance. Well, there can be a ratio between that distance and the distance between D and E, which is here. And because my triangles are similar, we can create a scale factor. We can set these two up as a ratio and build a scale factor, and it looks like this. AB over DE. And I chose to put AB on top because AB, or triangle ABC, came first. And what's the distance between A and B? And what's the distance between D and E? Those reduce down by 4, each of them can be. 8 divided by 4 is 2. 12 divided by 4 is 3. And there is my scale factor. So then let's look at that second one. What's the scale factor of DEF to ABC? What do you notice the difference between this question and the one we just did? There you go, I heard it. It flipped them. Triangle number 2 now comes first. So I'm going to write DF, or E, over AB. The numbers don't change. They just change where they were. Now it's 12 over 8. Those both can be divided by 4, which equals 3 over 2. And there's my scale factor from triangle DEF to triangle ABC. The next question asks, what is the ratio of the perimeter from triangle DEF to ABC? Well, the perimeter for DEF, for the sake of time, I'm going to tell you, is 48. Perimeter is you add up all the sides. And perimeter for triangle ABC is 32. So we have 48 because it came first over 32. And it's going to simplify down to 3 over 2 as well. And I know this is accurate because my notes told me if polygons are similar, then their perimeters are proportional as well. Which, do you notice that 3 over 2 is the same thing as 3 over 2 there? Okay, sweet. Similarity statement. We already drew it, but the symbol for similarity is like this sideways S. And we already wrote a similarity statement. We actually did it right here for these two triangles, and it says a valid similarity statement must match corresponding angles and sides. So let's just rewrite what we wrote. Triangle ABC is similar to triangle DEF. Then this next little problem down here says, list all congruent angles and write a proportion that relates to the corresponding sides. So I have two things given to me. I have a similarity statement, and then I have this diagram. Does my diagram show me any congruent angles? No, but my similarity statement does, doesn't it? So I can take my similarity statement. Triangle JKL is similar to triangle PMN. And I can remember that parts go with parts. So now, real easily, I can tell that angle J is congruent to angle P. And I could actually write that into my diagram with congruent tick marks. Angle K is congruent to angle M. Angle L is congruent to angle N. That part of the question's done. Then it wants me to write a proportion. And remember, a proportion is two or more ratios in an equation equal to each other with the corresponding sides. So I'm going to pick a side in the first triangle, JK. What's the proportional side in the second triangle? It is PM. Good job. So JK over PM is equal to my next side. I'm going to pick KL. Which one's proportional to KL? MN. So KL MN. And that's equal to the last side in my diagram, which is going to be JL and PN, or you could say it backwards. You could say LJ over NP. Okay, what time do we get out of here? Fourth period, 4 minutes. So you have a worksheet today. You're doing the whole worksheet 1 through 8. You'll notice that the questions have multiple parts. It's not due until Tuesday. I'm going to, I have recorded your lesson. I will edit it, post it in Google Classroom. I will have a lesson for tomorrow in Google Classroom as well. If it was me and you are able, I would watch it tonight because I will post it tonight. Watch it this evening. Come to school tomorrow, get your worksheet and work on the worksheet. Then you're done for the weekend. Okay? Coolio.